Welcome back, class number 59. So far, that is till class number 58, we considered so many questions where UDL was considered, sometimes sometimes left side, sometimes right side, sometimes in between, and then along with point loads. Plenty of questions solved. Now I'll solve a question, a special question. UDL only for full span, but not same intensity. See the question. A simply support beam of span 20 meter. I'll put here now. How is the beam? The beam is like this. Span is 20 meter. This is how, by seeing the words, you should convert to sketch. It is 12 meter, loaded by an UDL of 25 kN per meter, 12 meter long, starting from left hand. So, for 12 meter length, that is more than half the span, around 12 meter. Not around, exact 12 meter given. 25 kilonewton per meter. And then another UDL of 6 kN per meter for remaining length. I will show it lesser. This is 6 kN per meter for remaining length. This is A, this is B. Now this is the given beam. Given beam, for which you have drawn SFD BMD. Now, those who are interested, one small important note. How somebody will ask, some can ask, how such a loading comes. See, for example, imagine a beam supporting a slab. Slab comes only up to here. Maybe it transfers a load of 25, that is 19 kilonewton per meter. Maybe the slab is resting on the beam only for 12 meter. Actually 12 meter is too long, understanding. Span 20 meter. But this beam has its own self weight. Just imagine that self weight is 6 kN per meter. Therefore, the beam will have throughout UDL of self weight 6 kN per meter. 6 kN per meter. So, if you add these two, see, for this portion, 19 kN per meter plus 6 will become 25 kN per meter. Remaining length only 6 kN per meter. Just to understand why practically such situation will come. Okay. Now, in strength of materials, now onwards, I will not discuss too much about these things. These all I will discuss in my classes where I consider practical design. Okay, start. First, calculation of support reactions. Support reactions. As usual, let VA and VB, I told, I am not writing. Start. One sketch here. VB, VA, little bigger. For a length of 12 meter, it is 25 kilonewton per meter. And thereafter, small UDL. Not small UDL, UDL of lesser intensity. What is small UDL? 6 kN per meter. Span is 20 meter. 20 meter. This will become 8 meter. You require loaded length. You are calculating it, not given. Start. Sigma, this is the point A. This is the point B. Sigma m about A equal to 0. Take clockwise positive. Minus VB into 20. Plus 25 into 12 is this UDL. 25 into 12 is the UDL multiplied by half of 12 is 12 by 2. That is moment of this UDL. Total load 25 into 12 into 12 by 2 plus another UDL 6 kN per meter for 8 meter into moment about this point. This will act here. So 12 outside is 10, 12 plus half of 8. Okay, 8 by 2 will do, equal to 0. Therefore, you get the value of VB. VB will come in kilonewton. See, I have not calculated earlier. I thought I will do it in front of you only. 128.4 kilonewton. 128.4 kN. Sigma V equal to 0, make upward positive, you get plus VA plus VB minus this total load 25 into 12 also minus 6 into 8. 6 into 8 equal to 0. Therefore, you get the value of VA, get the reaction VA. Minus 48 minus 25 into 12. 219.6 plus 219.6 kilometer. Or just your curiosity, actually not required. See, I will check the answer. You check it. Take moment about B. Regarding this, taking moment about A and moment about B, I will ask a very sensitive question later, not now. Start. Plus VA into 20 minus 25 into 12 into 8 plus 12 by 2 minus 6 into 8 into 8 by 2 equal to 0. First you will get VA. I'll check the answer. 6 into 8 into 4 plus 25 into 12 into 8 plus 12 by 2. E divided by 20 comes to 219.6. Same answer. Sigma V0, you get the value of VB. Okay, now ready for SFD BMD. Ready for SFD BMD. Okay, little spreading of the ink only. Okay, now start. Shear force calculation. I wrote it, but I wrote it because some changes are there. Start. Shear force at A, just to right side you have to come, plus 219.6. Shear force at C. See, there is no point load in between. So that just to left, just right, double calculation is not there. Shear force at C. Previous value 219.6 minus 25 into 12 will give you minus 80.4. Lastly, shear force at B. Previous value minus 80.4 minus 6 into 8 minus 128.4. And as usual, variation. Linear from A to C and again linear from C to B. But you should observe one thing. Rate of change of shear force is intensity of load. That is nothing but slope of shear force diagram. Here intensity is more, intensity is lesser. So this should have more slope, this should have lesser slope. This is more steep compared this one. Compare this one, this side should be little flat. If this is so steep, next one little flat. Anyway, you can make out now. See, draw the diagram. Go up by 219.6. Don't see the calculation. I told not required. You don't have to bother about calculation. This is once you understand 219.6. From A to C, come down by 12 in 25 into 12. So 219.6 minus 25 into 12 will give you minus 80.4 here. See, minus 80.4. 219 is 100 here. So little lesser. See, somewhat scale. Okay. Okay, done. 80.4. Joined by a straight line. See, it will come this way. Now, from C to D, again come down by 6 into 8. But when you reach here, minus 6 into 8. 128.4. See here, 128.4 compared to 80.4, little more. See, this is 219. 128.4. Now, again linear. You can see here, this is more steep. This has become flat. Slope for this plane will be 25. Slope for this plane will be only 6 over. This is the SFD plus minus. Now, okay. Go back and draw SFD. SFD over. Usual question. Observe SFD. Yes, observing. Is SFD crossing base line anywhere? Yes. Where? Somewhere between A and C. Is it known or unknown point? Unknown point. Then name it. A, B, C, say D. Round off. Let it be X from here. If that is X, this will be 12 minus X. Okay. Now, location of the point between A and C where SF is 0, say D at X from me. Now I will not explain. I will not write, I will explain. Your X will come. Sometime people will tell, sir, last time you told without locating X, you can find maximum BM. Okay, I will get that answer first now. I don't know what is the X value. I write the answer here. 964, okay, it should be visible. 964.4832. That is the maximum BM. I'll check once again. Yes, correct. See, I have not located the point D or not calculated X. Means some tricks are there. Actually, not tricks. Some principles are there. Later I will tell, not now. Time being, you do systematically. Going to tricks or shortcuts will be only after you master it. Not in a hurry. Don't be in a hurry to go for it. X will come. 8.784 meter. 8.784 meter. So I'll enter here X equal to 8.784 meter. Therefore, this will come minus 12, 3.216 meter. 3.216 meter from here. Or I check from this side. That will be 80.4 divided by 25. Oh, I told the hint for you. 3.216. Okay. Anyway, those who are interested, option 1, 219.6 divided by X equal to 80.4 by 12 minus X. You get by similar triangles because linear variation. Option 2, shear force here equal to, see, at X from here, 219.6 minus 25 into X equate to 0, you get X. Last is mathematical trick. I already told you earlier, use it. I have been repeatedly telling that one, that mathematical concept. Okay, get it. Now, we have to go for BM calculation. I'll continue BM calculation here only. This I'll remove. Okay, all over. Okay, I'll go for BM calculation. 8.784. Okay, no second round, first round only. See. Then I'll do one thing, one extra question will be for you. See, BM calculation. Calculations, sagging positive. Start. BM at A. 0. Oh, I wrote the answer. See, I rubbed it by mistake. But you can see it later. I don't know how much I wrote. We will see. Answer will come now. Then you go back and see what answer I wrote. Then BM at C equal to, look this side, plus 219.6 into 12 minus 25 into 12 into 12 by 2. Sometimes it happens. Some people will tell, he is not explaining everything. My answer, how many times I have to explain? Earlier classes, all this, how slowly and thoroughly, systematically explain. You come through all the classes, then only you get the perfect knowledge. It is 219.6 into 12 minus 25 into 12 into 12 by 2. It will give you plus 835 plus 835.2 kilonewton meter. Then BM at B equal to 0. Okay. Now, next. You should write a note. All standard points BM over. But you should also find BM at the point D where SFD is crossing baseline. See. Also, you require BM at D. That is the point where shearing force diagram is crossing baseline or where shear force is 0. Okay. Look this side. Plus 219.6. See, now I am using this value. But earlier I wrote that value without using it. Plus 219.6 into 8.784. 219.8 is to 6 into 8.784 minus 25 into 8.784 into 8.784 divided by 2 will give the BM. Now testing time has come. What answer I told earlier, whether that answer comes or not, you can make out now. 219.6 into 8.784 minus 25 into 8.784 into 8.784 divided by 2 plus 964.4832. Now you go back in the video, see what value I wrote. It is surely same value, or I will again check it. I won't see this x value. $964.4832. Yes. Over. Now, next, BM variation. How it is parabolic of second degree for A, not for, I'll write here, between A and C, one parabola, and another parabola, and C and B. Okay, now go back and draw bending moment diagram. Start. First, little be careful now. Important concepts are there. Bending moment diagram. All values are kilonewton meter. Sagging positive. I forgot right here. Not required. SFD. All values are in kilonewton. Left up, right down, positive. BM at T came 835.2. See, 835.2. I'll do one thing. I'll check from that side, just for safer side. 128.4 into 8 minus 6 into 8 into 4. Yes, 835.2. And BM here came 964. That is, it is 835 means 400, 200, around 835, 130 more. 400, 200, see, little more. This point, not too much more, slightly more. Okay, how much it is? 964.4832. Now, A to C should be one parabola. See, it will reach the peak value here, highest value, then will drop here. See, this way. This is the maximum BM here. Over. See, this tangent will make a slope of how much? 80.4. Both sides same. Now, here to here, again one more parabola. Actually, it is not this parabola. See, this is one parabola. This is another parabola, but even for both the parabolas here, slope will be same. Therefore, if I draw a tangent here, same, see, suppose I draw a tangent here, same tangent should come for this also. Oh, it shifted. Okay, I'll put that side. Okay. That is, it should have common tangent. I'll do one thing now, see. Actually, these all you need not worry too much actually. Okay, now correct. That is, this is, if I draw tangent here and tangent here, both see, for this side, what tangent you get, same tangent should be that side, but then the curve ordinates will change. This is bending moment diagram. I do the bending moment diagram to the best possible way in this board. So, that's important points I told. But remember, this is one parabola, this is another parabola. This is bending moment diagram. Now, I will do one thing. For you, I will give a practice question. Direct answer. See, solve this question. I will directly give the answer. Nothing much. I will do one thing now. This side I will put higher UDL. This side lesser UDL. Span, both of them are say 4 meter and 4 meter equal. It is of no use for you still. UDL 20 kN per meter, 50 kN per meter. I'll give direct answer. No hint, nothing. One ten minus, check the answer, 50 into 4 into 2 plus 20 into 4 into 6 divided by 8. 110, correct. 110 minus 20 into 4 is 30. Still you are above the waistline. See, this is 30. No, see, further lesser. 110, 30 is 110 half 50. It should be reasonably correct. See, 30. This is 30. Then here 170. More steep. Suddenly it will become steep here. See, 170. This point from here will come and 30. I think little bigger required. Okay. And as long as you understand, it's okay. So 1 minute. As long as you understand, purpose is served. 170 means it is not matching. Okay. 30. This is 170. This point from here, I will calculate later. Bending moment. See, I will give the maximum BM without locating this point. Then I will tell the point. Here. $280 here. This point is 280. Not that point, this point, 280. This point, bending moment is 289, slightly more. 289 or that distance. Now I will tell the distance. That will come 3.4 meter. Now if you want, check the bending moment here. 170 into 3.4 minus 50 into 3.4 into 3.4 by 2 is 289. Now see, this point to this point, one parabola. One parabola from here to here. Then same slope, it will come peak value, then it will come this way. See, little odd shape here, I will make it smooth. Okay, reasonably okay. See, highest value here, then it will drop back here, plus is the bending moment diagram. Work out this question and thoroughly practice. I am given directly question with answer. No hint, nothing. Okay, we will meet you in the next class.